This is Calculus with Allenson, and we're going to do problem number 1 from the 2006 BC test. It's a calculator problem, so let's start off. A says to find the area of R between x minus 2 and natural log x. So we're going to take the integral from the x value here to the x value here, where those intersection points are. Now we're going to use our graphing calculator to set those two equations equal and find the intersection point on the graph screen. The two values we get are 0.15859 and 3.14619. Let's call those points S and T. So this is S and this is T. So we're going to integrate from S to T of the function on the top, ln x, minus the function on the bottom, x minus 2 dx. Plug that into your calculator and get 1.949. B says to find the volume of the solid generated when R is rotated around the horizontal line y equals -3. Now I can't show this because I have some stuff in the way here, but essentially what you're working with here is you're taking this region, rotating it, and you're going to get washers. So you have a large radius, which is the top function, plus 3. And you have a small radius, which is the bottom function, plus 3. So the volume is going to be pi times the integral from S to T of the large radius squared minus the small radius squared. Use your calculator and you should get either 34.198 or 34.199. Now the last part, C, says write but do not evaluate an integral expression that can be used to find the volume of the solid generated when R is rotated about the y-axis. So essentially when I have this rotated over here, and I have this kind of a shape going on. Washers again. Now we're integrating with respect to y. So we have a little bit different thing going on. We need to figure out what these functions are that with respect to solving for x instead of y here. So if I solve this one for x, I get x equals e to the y. If I solve this one for x, I get x equals y plus 2. So my large radius is equal to y plus 2, and my small radius is equal to e to the y. Now one other thing is that we need to integrate from this y value to this y value. And since those are both on this line, y equals x minus 2, I know the x values are s and t, and if I plug s and t in here, I get the y values are s minus 2 and t minus 2. This one's s, so this is s minus 2, and this is t minus 2. So I'm going to have pi times the integral from s minus 2 to t minus 2 of the large radius squared minus the small radius squared with respect to y. Now the points from this, 3 for each. A is worth 3 points. 1 point for the integrand, 1 point for the limits of integration, and I need to have them written somewhere else if I want to write s and t, and 1 point for the answer. B, 1 point for the answer and the limits of integration, and 2 points for the integrand. 1 for being in the form of pi big R squared minus little r squared, and 1 point for getting big R and little r right. C, 3 points, 2 points for the integrand, again the same thing as the previous one, and 1 point for the limits of integration.